Good afternoon. My name is Ivan Gutai. I will talk about a prototype of a system for detecting G-force in an automobile based on two ESP32 development boards. Key features of our prototype is that gives the automobile driver option to read current and maximal G-force in all three axes and to read the angle at which the vehicle is. The system consists of two parts. The first part is visible to the driver. The second part is in the trunk. 5-volt power supply powers both units. Modules communicate over Wi-Fi using ESP-NOW technology. While driving through corners, all passengers can get an interactive view of G-force. The system uses encrypted communications, and the most important part, the price of hardware can go to about $20 US, which makes it suitable for educational purposes. Also, this fits for the training of engineers in developing countries. In a current hardware configuration, it provides a choice for the user to see the strength of the G-force in the three axes while driving. If you ever wondered to what amount of force our body is exposed to while driving an automobile or facing a bump in a road, this prototype gives a lot of answers. One segment of the screen is dedicated to the interactive G-force meter shown as a graph. The prototype consists of two parts. The first part is visible to the driver, and it consists of ESP32 and one TFT display. The second part is for acquisition, and it consists of ESP32 VMOS D1R32 and MPU 9250 motion tracking sensor. In this paper, the accent is on modularity and ease of wireless data transfer using Espressif's ESP-NOW technology, which has encryption possibilities. The concept of dividing into smaller parts comes from programming and represents good practice. Dashboard component, which is first part, consists of ESP32 and TFT 2.8-inch display, which has a relatively small resolution and is powered by 5 volts and is in line with the dashboard. Connection indicator is located in the top right corner of the screen, and it's realized via green or red rectangle. For relatively small distance which Wi-Fi cross, it is unnecessary to use an external antenna for ESP32. Copper integrated antenna is just okay for this purpose. The display shows current and extreme values of G-force for X, Y, and Z axis. The user doesn't have to think about the labeling of the axis. And on the screen, just before numerical values, first letters are written off: front, back, left, top, and bottom. In front of current values, there are no letters. Acquired parameters from accelerometer make data for calculation of angles in which is the vehicle in every moment. Formulas on this slide shows whether the vehicle is on incline, decline, or is tilted. We use terms pitch and roll. Yes, they are from aviation, but it makes easier to understand the concept. Second part, which is actually trunk component, is a variant of ESP32 called VMOS D1 R32 and is selected because it is physically identical to Arduino Uno development system. It means that there are plenty of prototype shields or acrylic cases. We used Wi-Fi channel 14 because it's generally rarely used and there is less interference. ESP-NOW gives the possibility to send data to up to 20 devices over Wi-Fi. If we decide to use encryption, we must consider that LMK or local master key matches on the receiver and transmitter. On the receiver, receiving of data must be enabled, and the receiving data structure must match the transmitting data structure. This is one small part of the actual code. ESP-NOW technology allows up to 250 bytes to be sent from one to another device. We use approximately 50 bytes of data for this purpose. Here are addresses of both receiving and sending end. And in 3 lines of code, we can configure most important things like a channel, which is 14, like that next line is encryption. We need to set to true and some random number which we can choose. And what is most important, if we choose number 203, it must be on one end and on the other end. On display, there was a space for dynamically drawing a graph. It has 100 points and its content moves vertically. On top is located current value and preceding values are drawn below. When a vector is filled with the 100th value, the oldest value is removed, which creates a spot for the latest value. During the development of the prototype, the refresh rate of display between 40 milliseconds and 2 seconds is tested. For the city driving environment, it is enough for the chart to refresh every second. Every second, 100 measurements are made. This enables enough precision for using the prototype in everyday driving. Also, it's suitable for unexpected situations. Data transfer from one to another part takes place 30 times per second. Every second vector content is drawn in form of dots. Dots are interconnected, which enables the user to see the content of the graph to move down. During a regular city driving, G-forces in vehicle go up to 1.8 G. Graph is limited for drawing forces up to 1 G, but extreme values up to 16 G can be registered, which is maximum for use sensor. And one interesting thing that when we drive over a railroad crossing with a speed of 30 kilometers per hour, 1.5 G is registered from the bottom side of automobile. I see that 10 minutes is
yes. So please 1 minute to conclude the presentation, please.
Okay, here are some hardware details. I will tell the last dot using the display in MPU base system ensures us during fitting that the system is perfectly aligned. In that scenario, the accelerometer acquires values 0 on X and Y axis and value 1 on Z axis. If someone wants to see the code, we can discuss about that in other in discussion room. And this is proof of concept that under $20 we can choose a hardware and we can build actual prototype, and we can delve into test or development for various we have various possibilities with relatively small amount of invested money, and I would call it this combination of hardware affordable dev kit EE, dev as a developer and EE as an emerging economy. Thank you for your attention, and if you have any questions, I will be glad to answer.
You said that this prototype gives a lot of answers.